Hello, everyone. Welcome at the core protocol sync. We'll describe changes to the node, farmer, DSN, and related things from the last week and plans for the immediate future. And the first one sharing updates today will be Shamil.
Okay. Last week, I added a second part to the enabling object mapping handling on the farmer side. The first part that was adding the request response protocol to the networking was done 3 weeks ago, if I'm not mistaken, and this is the second part. I basically added a simple handler to that request response protocol. Also, last week,
sorry, Shamil, what does that allow for that we didn't have before?
Yes, we have now a way to get object mappings by object ID using the DSN. It's using the request response protocols as part of the DSN.
Okay, so before we could just request by piece index, now we can actually request objects and then iteratively look up the pieces and reconstruct them.
Previously, would have to find object mappings elsewhere. It wasn't on the DSN.
Okay, awesome. So that's been merged and tested?
No, I don't believe that it was tested. Outside that, our local tests or M examples, I'm not sure that it will be tested on some production grade testing stand.
Okay, is that on the board right now?
The very tickets, I think they're not sorted when you close them. So when you close them, they're not at the top in the close section.
Okay, so it's just somewhere in the huge backlog of closed. Okay, cool. Okay, sorry, go ahead, Evelyn.
Also, yes, I tried some different approaches to limit our connections to our nodes. The first attempt was to limit connections on the swarm, which is the GAD object for the networking instance. But it has several limitations, and also we found that by default we don't keep alive our connections, and the basic algorithm which was limit connections and then try to connect again to some, let's say, reserved peers, or to maintain minimum amount of connected peers. It causes permanent reconnection, which is obviously not good. And the second attempt I made, I implemented the same feature by using some event of the swarm connection established. That's allowed me just to disconnect newly connected peers if we exceed some threshold. It's basically allowed us to not reconnect multiple times. So that was a good finding. Also, I spent time for researching Subspace sync.
Shamil, just a couple questions on that.
Yeah, sure,
what issue number was that you just described?
I'm not sure. Let me find it.
And so I understand the problem. So on the DSN, sometimes farmers will just continuously reconnect to a peer, like in a loop.
Yes, we have a notion of minimum connected peers.
That would be the case if we are doing keep alive. It will just keep connections forever and just connecting more and more and more.
And we do have this now because we added a minimum connected peers number. So when we in some time disconnect from these peers, if there is no exchanges of messages between those peers, we disconnect from them. And if we disconnect to many of those peers, we connect them again using our minimum connections number. And also we keep, if you remember from probably 2 weeks ago, we added a concept of local storage of known peers. So we get those peers from the local storage, and if we fall below this minimum threshold, we get these peers from local storage and try to connect them again to maintain this minimum connected peer network for each peers in the whole DSN. It will eventually creates some retries, reconnects, but it's better than currently. The current algorithm of connection limits is better than the previous one for sure.
What is the minimum count right now?
It's adjustable by CLI parameters.
What's the default?
25 probably.
Okay. So, and if I can't find 25 peers, what do I do?
You keep trying using your local known peer cache.
Actually, I think we need to upgrade that because we already have random walks on the Kademlia DHT, so we can maybe use some of those if we have tried all of those in our like storage.
Those peers will be added also to this known peers cache,
Oh,
and we will
okay.
try that.
Okay, cool.
Okay. So, what was the issue? Were you able to find that, Shamil?
Sorry, I was distracted to our conversation.
my bad.
Give me a couple of seconds.
Okay.
I think it's
So-
776.
Okay. That has also been merged, or it's complete?
Yes, it was merged.
Okay, and tested locally.
Yep.
So these are being deployed into pre-stress test, right? Or is this a separate branch?
Yes, I believe all of them are pulled in there. Yeah.
Okay, and are the farmers on are the nodes on pre-stress test automatically joining the DSN, or is it opt-in?
We need to have a bootstrap node for DSN deployed somewhere, and we didn't yet.
Okay.
If we do in specify parameter, they will join, but it's not the default.
Okay, so it's not so we're not okay. So we're really just testing this locally, right?
I posted the issue
Thank
in
you,
our chat.
Okay. All right. Go ahead.
I started to gather information for the more complex algorithm, and I started to the second iteration of Subspace sync research. We had a page which we compose of facts, known facts about substrate sync. It was started by Nazar, I believe, and I added at least one fact to that list, which is about simultaneously. It is a parallel downloads of the blocks. It was missing in the page. So that's it, and
This is in Notion?
Yep, and I'm going to continue this probably updates with our consensus, and after that I will probably go to the different blockchains like Filecoin. I believe will be the first choice.
Can you? Yeah, thanks, Nazar. Okay. So this is our current documentation on how sync works in Substrate. Okay. And so Shamil, you're just verifying this or trying to extend it or make it more
Yes,
more
it was
featureful?
previously merged in that DSM sync and history page. I get it from in the separate page and update it with new facts.
Okay, cool. And what are you looking at Filecoin for?
My main goal is to find how do they make a sync process. What will with their optimization techniques? I want to find how will they make it optimized. Initial research showed that they have different concepts of storage and retrieval nodes, as they call it. You could know this as storage miners and retrieval miners. It's a new concept for them. They're been developing it, and this way I try to look at. At first, it seems that they don't do any parallel downloads, but I'm not sure that it's the case. I need to spend more time on that.
Okay, are we talking about? Go ahead, sir.
I think it's a little bit different because they're not storing the history of the blockchain like in the DSN, right?
Yep.
So
That's
it's
correct.
a little bit different use case.
But they need to somehow synchronize the data between storage miners in order to get it to maintain some replication factor. this what I would do, because if only a single miner will get that data, it's a little bit dangerous.
Okay, I see.
They also have the concept of faulted segments, which I believe could handle some situations that a miner cannot get its data, cannot retrieve its data. But I'm not sure that this is the only technique that they implement. Because
I don't know how it works, but I can deduce that it might potentially be not solved on the protocol level, because you have a contract with particular miners. If they're offline, you can basically prove that they're offline and get some kind of refund and establish a contract with someone else. Maybe I don't know, but maybe they just offloaded that onto the user, to periodically check and
probably
explicitly.
It could be a case. And however, my main theory for now is that the retrieval miners, as they called it, could get also the data and to exchange between each other for some protocol. It's a little bit complicated that they demand payment for each data retrieval using those markets algorithms, ask market and bid market. So this is what I'm reading right now. And I want to compare
a couple questions in that, Shamil.
Yes,
so the Notion document that Nizar shared, that's about syncing the history of the blockchain for a Substrate client. But you're talking about syncing a plot or the DSN, which is orthogonal to the history with Filecoin research. So these are two different sync algorithms that we're talking about.
Absolutely different blockchain.
Okay.
I want to get some.
Well, I mean, not different blockchain. I mean, are we talking, when you're looking at Filecoin, you're talking about syncing the history of the DSN, which is different from syncing the history of the blockchain for the node? Or I guess I'm a little bit confused here.
You're correct.
Okay.
For Substrate, it's the history of blocks, and for Filecoin, I don't interest in the history of blocks. I want to get some techniques for the data exchange.
Okay. I think that, I mean, Filecoin is a completely different protocol, honestly, in terms of how it works and how it's designed. So, I mean, I don't know how useful that's going to be unless we decide to redesign our protocol, to be different. I think
sorry, Jeremiah. I think that they have similar problems to us, to exchange pieces or segments. They also have both notions. And I think I want to have some inspiration probably from their code.
Mm-hmm. I mean, they do have ways to handle that, but they have a whole different notion of who's what the policy is for assigning things, which make that, a solution to sort of a different problem than we have. So I mean, that would be saying I'm going to look at I don't know, proof of stake as how proof of stake consensus works, see if I can improve proof of work consensus. They're both solving a consensus problem, but they do it in such different ways that they don't necessarily how you solve it in one way doesn't translate to the other. So we're a DSN like Filecoin, but we have very different set of assumptions. So I'm just afraid you're going to be kind of spinning your wheels looking at what they're doing when there's not going to be much actual useful, and it's a insanely complex protocol. It makes what we're do look so simple in comparison.
Yes, you're right, and I don't want to spend too much time on it. I will finish, let's say, in a day or two. But what protocol would you recommend as the next one to look at?
I think it would be more valuable for you to try to document the sync process in Substrate of just the client, of the Substrate node, and try to document what ours is and what it should be compared to Bitcoin, for example, just a very vanilla proof of work consensus. And that's sort of the more fundamental problem we have. And then the DSN, honestly, I think a lot of that's going to change as we go into consensus v2, because there's going to be some implications for changing the the structure of the DSN around that. And I feel like anything you do right now is going to be a little bit wasted effort until we have that defined.
Okay, but Substrate sync has fundamental different parameters, because they have fixed block height, and we don't. We need to synchronize some pieces within some range, so we can't.
Well, the challenge is that next consensus will have different mechanism as to what pieces you're storing and how you're storing them. So the algorithm will be different as well. It will not be the same kind of behavior we see right now with the network. So
Okay,
I don't agree with Jeremiah.
That I think we need just to have our call about this changes in sync.
Yeah, we're still gonna have like request response and a lot of the stuff that y'all have been working on. Like we still have a DSN, we still have a DHT, we still have a notion of like pieces that farmers store. We still have a way to like address those pieces. We still have like mapping. So all that's going to stay the same. I think I wouldn't get too worried about like optimizing things right now until we have a better idea of the structure. Like the bigger problem right now is just this actual syncing algorithm that we have and making sure that that is compatible at the network layer.
Syncing algorithm, do you mean block syncing or
yes,
PC syncing?
Block syncing.
Oh, this is not what I'm looking at now. Probably we should talk with Nazar about this.
Okay, I guess since that was the document that Nazar shared, I thought that you were working on that, but maybe that was just for something else.
Okay, when you will have time, we definitely need to have a call.
Okay. Okay. And what are you working on this week, Shamil?
I don't have any pending coding tasks, so I will continue with the research. So if you have 20 minutes in your
it's one of my priorities to come up with more tasks based on the plan we had and corrections.
Okay. How much more time have you got today, Shamil, for your work schedule? Like how many more hours until you're checking out for the day?
I think 2-3 hours. 2 hours is my just usual schedule, but if you need more time, we will put.
Okay, maybe after Nazar and I are going to have a sync after this, and maybe after that we can try to find a little bit of time to talk more about this DSN and sync together.
In an hour, is it correct estimation?
Out like hour and a half ish.
Okay.
Yeah.
Makes sense.
Okay, cool. Okay, thanks.
Are we good here?
Yeah. Sorry, I had so many questions.
It's okay. Okay, Ivan, what about you?
Yeah, sure. Let me just share a screen. I don't have like much updates from my end. I was basically mainly working on the removing RocksDB from the Subspace farmer and like adding the integrations for that. Migrations for that. So yeah, it's kind of minor PR. Like the main things which I wanted to highlight is that I decided to not create the migration for the commitments and just basically burn them. Let me just find the code. If I succeeded in trying to read the opening the commitments database. Oh yeah, here it is. Yep. I just basically remove the directory and create the new one, but for the syntax hash to offset database, I basically create like a separate migration code. The thing is that it will need like 2x like memory for the it will remove the database only after the migration, so that would require like some amount of space. That's what I wanted to show from the PartyDB migration PR. Also I was working on the including object mapping routes.
Question on that?
Yeah, sure.
So this is going to allow us to remove RocksDB entirely from our dependencies?
Yep, true. Like after the, I believe, like in the next
Actually,
iteration.
very soon, because we will launch new network hopefully without RocksDB support in the first place. So everyone will wipe everything anyway.
Yeah.
Okay.
Yeah, it would be great. Yeah, if we would launch like with support of the parity DB. Yeah. Right now, like the thing is, like in the previous like iteration of the migration for the parity DB, I basically added the benchmarking time here, like in order to compare the general like recommitment time and etc. So basically, I don't have like any benchmarks here yet. Yeah. I decided to like run benchmarks beforehand the meeting, and yeah, I hit some of the issues. So yeah, I will spend some time and investigate more. Like I just basically overflowed my stack, which is weird. Yeah, we'll take a look at that also.
Are you waiting to do that testing before you submit this for review?
No, it's ready for the review. Yeah, I just.
I already have some comments. I just didn't submit them because I didn't read the whole thing through.
Oh, okay. We'll be waiting on them.
Okay. Do you think that can be closed out by the time we launch stress test?
Like today's one, or
no, the proper stress test.
when it will be like yeah,
like later this week.
Oh yeah, I think yeah, sure, of course.
Okay. Yeah, it'd be great to close this one out if you can make that your priority.
Yeah, sure, of course, yeah. Okay. Either way, I don't have like any tickets in my head to work on apart from this one. Yeah, I already had a take on the adding the object mapping roots into the header. Like we had discussion with Nazar here about that. Basically, I just reused the Merkle tree from the records root, and apart from that, I believe like we basically have the structure which is called the root block. Yep, and not the structure, but enum, which is supposed to be supposed to have like the migrations and etc. So yeah, I just basically added the object mapping root there. Yeah, but instead I just suggested to create like whole different enum variant for that. Yeah, so
well, I think overall this task is probably going to be deprioritized completely because the way object mappings will work with domains will probably be significantly different.
Oh.
So whatever effort we are spending here will probably just throw it away. So I wouldn't focus too much on this.
Oh, okay.
Well, let me just add something to that. So we will, I think we will still have a notion of a records root, but it will be under a polynomial commitment scheme versus under a Merkle tree. So I think the structure will be the same, but the particular commitment scheme we use will probably change. Now the location will change as well, like where this logic actually occurs. But I believe we're still going to be retaining this notion of records root and verifiability of records within the
concept
object.
For sure. Yeah.
Yeah.
I think we can just mark that issue as non-priority and close the pull request for now, and we can go back to it and then revise if necessary.
Sure. Yeah. Yeah. Let me just close it and yeah. Yeah. Move it.
Another question on that, just for me, it'd be helpful to conceptually understand. So how do we actually, like, the actual commitments database is not maintained in the node state, it's maintained on the farmer state. So how do we like recreate the new Merkle root if we don't have that data?
Are we talking about the commitments or the object mappings?
The object mappings.
Oh, we're actually it's created for each of the segments basically. So these object mapping roots.
Oh, just the object mappings for this segment. So we don't have a notion. Okay, got it. Okay, that makes more sense.
Yeah.
Thanks.
Yeah. So this week, I guess I will finalize the migration of the parity DB to the parity DB. yeah, I don't have any like other tasks like in my head. So yeah, I probably will spend some time also thinking about like other tasks which you can do in the meantime. So yeah, that's it.
Do you have anything in mind for Ivan to work on this week?
I'll need to think about it. I was just occupied with different things last few days. Just didn't have time to think about it. I'm sure we'll
I
find
kind of
something.
have a question about something that Ivan talked, but it's more for Jeremiah and Nazar. So we do not have this notion of object mappings and so on and so forth in the spec, like at all. Do we want to have it?
I think we don't have it in the consensus spec, but I'm pretty sure that it was described in one of the documents that Srivatsan had wrote. I just don't think we're actively using that anymore. But we do, this goes back to the conversation we need to have with Shamil after this, is we need like some kind of a spec or an overview of how this whole system works that we can have as like a common source of reference. And it should eventually be as formal as the consensus spec that we have
Because
right now.
if, like for instance, if the object mapping roots are stored like along with the segment roots, it's like very intervened, you know. And the way the current spec is written is just as if those things don't exist, basically.
Yeah,
they're added on top. I don't remember if I documented somewhere, but basically there was like one version of the design that didn't quite work in terms of the implementation, and I was like iterating on it until it actually clicked and worked, start to finish. But that final version is for sure not documented anywhere. We can have like a small call. I can like walk it through and explain things. Maybe you can help me with that.
okay. So I think maybe what you're getting at, Daria, is the challenge is that the code is getting ahead of the spec, and it's hard for you to keep track of it and keep it up to date.
I mean, code is the spec. The spec is like,
yeah, it's just the thing is more that like I feel like I have too many blind spots right now, you know, out of that.
Yeah.
About how this things works, and it's hard for me to tell whether this is something that is that important on consensus level, or whether something is just an implementation detail, or whether it should be. So, for example, there are like again the execution layer is not there, and it's something that I feel like I know nothing about when I should. And things like the way pieces and objects are reconstructed is again something that I didn't look neither in the code nor the documents, and I know nothing about at this point, but I should, to be able to reason about the whole consensus and protocol in, you know, the level that you do, Jeremiah, for instance.
Yeah, that's fair. We've tried to just focus on consensus right now until you're on full time. But it is definitely in the scope of what we're going to try to do is to get every layer incorporated. However, the consensus is kind of designed to be modular such that these other things shouldn't impact consensus. There might be some like metadata which gets incorporated in a block header, but it should not really impact the core consensus mechanism itself. So I understand your concern, it's fair, but this is kind of like decoupled consensus is really the idea here, to alleviate that somewhat. I think, but there's definitely a problem here of like trying to like keep this up to date. I'm just curious, Ivan and Shamil, have you guys read the latest version of Consensus V1, like end to end, the specification? Are you guys familiar with that?
V2 you meant?
V1, the current consensus.
Oh, the current. Okay, yes, sure.
You have?
Yes, I'm not sure that I have it 100% in my operating memory, but yes, I read it twice or 3 times at the very least.
Okay. Ivan, you have it as well?
Yeah, I believe right after right after I was being by Daria. Yeah.
Okay.
Yeah, it was
So I
finished
think
like a few weeks back.
okay, great. So I think that the takeaway here is you guys should be, everybody really should be very familiar with the intricacies of that specification. And if something does change, you guys really need to let Daria know. Like it's not realistic for her to like review line by line every code commit that comes through and expect her to be able to keep up with that, or for her to like infer from the meetings what's going to happen. So you guys need to be familiar with that specification. And if you're going to change something or update something on specification, then you guys need to make sure to let her know. And eventually, like once we have like a mainnet, we're going to be at the point where code does not get written until a spec change has been submitted and approved, and then we will go into like actually changing, something that impacts consensus versus like the opposite. But it's gonna take us time to get into that kind of a mindset.
Is farmer synchronization part of that spec now?
There's a separate spec. It's not part of the consensus, but it is certainly something that needs to be documented.
So, okay.
Yeah.
Thank you.
And I believe, Shamil, that
No.
you right now have the best knowledge of it. So if you could document it the way that I could look at it and read it in like whatever, half an hour, would be like perfect.
Okay, so you are going to write a spec about it.
No, I thought you should.
She's asking if, and I think this would be valuable, if you could at least, like just in English, like plain English, not in like, formal terms, describe how it works. And then Daria could take that and make it into, like, start drafting a spec from that. But she doesn't even understand conceptually how it works right now because it's not documented anywhere.
I was going to ask Daria for several minutes after this call so we could discuss it in more details. Do you have time, Daria?
Maybe I think like tomorrow would be better. So, but
Okay.
let's chat and then see sometime.
Okay.
Thanks.
Okay. That took a little bit longer than expected. Let me share my that's then. This should be the one. Hope you can see it. So I'll skip this change. I'll explain why. This one just deletes chain specs from the Subspace node. So we dropped compatibility earlier, but there was still a chain spec you can technically try to run, but it will break in many interesting ways. After that, there was this long-standing challenge where the max plot size was not in bytes. In multiple places, we have changed that on RPC level and on the farmer, but the consensus still was operating with bytes. So what I changed in this pull request, it's actually no longer a constant. It is something you can define during the chain creation in the chain spec in Genesis config, such that when we have chain specification, we can customize the size of the max plot size for every particular chain. So we can have dev chain with one size, you can have other dev chain with a different size, you can have production with the third size. The rest of the code base is like flexible. It doesn't assume any particular size, it will read it from consensus. So this is the change in this pull request, mostly mechanical, just replacing things here and there. We had that as a parameter kind of already.
Is there a quick question on that?
Yeah.
That's awesome, by the way. I've been hoping we could have something like that for a long time. How much of the other constants, like I guess how hard is that sort of workflow or that kind of process to implement such that we could have even more constants which could be configurable for different development environments that are currently hard-coded?
If you're talking about setting them at Genesis, we can basically do all of them. And that was actually kind of the idea I've discussed with Lucian a while ago, and I was like suggesting for us to have more of those, such that we can have one runtime and just configure it whatever shape you need for a particular test or use case or whatever. So right now we can enable disable rewards, we can enable disable storage access, we can enable disable executor, and this is just one more parameter. We can have as many of those as we want. It's more tricky to like change some of those on the fly. It's not always possible, But setting a Genesis, it's easy.
Awesome. Yeah, I think we should definitely do as much of that as we can. And that's what I meant at Genesis, not on the fly. Great.
Yeah, I guess it's less efficient if you are reading it from storage all the time. So if you have like a lot of these, we probably want to like accumulate them in like Genesis kind of parameters, so you can read it once and have all of that available. But otherwise, yeah, it's not a problem. Okay. Let me see what this one is. I cannot recall. Yeah, I think this is also irrelevant. I'll explain later why. Then in one of the recent pull requests, we had this legacy farming kind of abstraction in the farmer, and we have switched to the more modern one that remembers how big your plot was, remembers the Genesis hash and stuff like that. However, there wasn't an update for wipe and info commands, so you couldn't run them at all. So this was a small fix to unify all of those. So you can wipe and print information about your farm, like what Genesis, like for what chain it was created, essentially. And some of the other things, it's fairly trivial. Then this was an interesting, tricky situation. We had a problem way in the past when commitments caused problems for plotting, and we have fixed that. However, in this modern single plot farm, there is a concept of single disk semaphore, which basically limits how many heavy things you can do with the disk at the same time. And it forces other things to wait while the previous things have completed. So one of those things is commitments, and the other one was plotting. However, if you have commitments creating, and you have two of them created for the same disk at the same time, which is the case if you have like multiple small plots on the disk, then you're basically out of luck and you cannot plot anything anymore. So in this case, I just disabled, like commented out this piece of code to not block here, so we can still plot while commitments are created, and left a comment that in the future, this may or may not be a problem and we will need to rethink. But this basically fixes some of the challenges that we have discovered during pre-test test, and this is the root cause of that. And then the meat of this review, I think. No. Yeah, this is one of the big ones. Fast sync support is removed. There were several challenges. I was fixing some of those in the pull request I just skipped. I have fixed some of those locally before I submitted this pull request. The end result is it's very tricky and very complex, and it's better to just remove it for now, and in the future to switch to the light client. The idea was to optimize more for reads, so we can read things on every block, but you don't have to write on every block. But that's very tricky to manage in terms of forks and everything. So I think we'll just do the same thing that light client does, and for every block we will store its like local state kind of in the auxiliary storage, so that in the next block we can read information from the parent block and make our decisions about like what the salt should be or what the randomness when the randomness change happens and stuff like that. The way it was implemented was too tricky. No one was able to follow what is happening there, I believe, and it's really, really hard to fix. So I just decided it's not worth it. The whole complexity, we can just go with a simpler one and just write one item on every block import. That should not be a big deal. So yeah, just 800 lines of code deleted. The meat actually is this upcoming pull request. Tests are currently failing. We are figuring out with Luchain why. We have some ideas, but basically there is this upstream pull request I submitted later that fixes some of the major sync detection that was fixed and then broken again in Substrate. Plus, it implements some additional logic. So there is a CLI parameter to force node think that it is synced. This is necessary for bootstrapping. There is a description why that is necessary. And then in the protocol on network level, we are not only sending the information like about block announcement, just the header, we always include information whether the node thinks it is synced at this point in time. And then when we are deciding whether we need, let me see where it is. There is a lot of things here. But when we are deciding what the block target is to which we need to sync, in here we just skip the peers that are not synced. We just ignore them. And with those two things, the sync success should be much better. It should actually be 100%. And that's what we will be testing or are already testing today on the pre-stress test. There is probably a small update to this that Lucien suggested in the review. But otherwise, just follow this to read changes on the substrate side. It's our fork, which we'll be using for a while, I think. And read changes in this pull request. I'm not sure why they are so big. Yeah, it's just a log file. There is one tricky part on the block production. So on the Genesis node that like starts bootstraps the network, it needs to produce some blocks, ideally. However, it is not in a position to do so because it's not synced itself. It doesn't have any peers at all. So we have this parameter in Substrate called forced authoring that we can force node to try to produce a block. However, is major syncing behavior has changed in our case. It depends on other peers, we should have none of. And since we know that slot worker actually uses sync oracle, we just create a custom sync oracle, which not only accounts for this is major syncing default behavior, but it also accounts for the forced authoring. So if you are forced authoring, you will never be like in major sync from the point of view of slot worker. So slot worker will not be stopped from producing blocks. If that is the case, it will always produce blocks, just like the CLI parameter says. Otherwise, I don't think there are many changes here. Mostly log files or cargo toml files. What's this? Yeah, this is just for tests on the executor side. So yeah, that was an interesting discovery over the weekend. It seems to work reasonably well in my testing. We'll see how it goes with the community.
Can you comment just a little bit about the fork or the fact that we're forking Substrate and kind of how we're going to manage that going forward?
Yeah, we have a precedent for that in the lib peer-to-peer case. What we have created in that case is just like a branch subspace v1. Once we are doing some breaking changes or rebasing, we are leaving this forever. So you can reference it in the future if you want to like build the older version or something. We'll just create v2, v3, v4 once we're doing breaking changes. And that will live under our org repository. Hopefully in the future, we'll not have to fork Substrate and we'll just be able to swap the sync process. Parity folks want to do that. It's just kind of tricky the way it's interleaved. So I'll have to spend more time thinking about how to abstract it away in a way that will be able to possible to swap the business logic of that. Right now, only like networking part is swapped, but the business logic is still in networking. Any questions about this one or anything before that?
So this idea of like a forced think will not be contributed back to the substrate.
So this pull request introduces the notion of like sharing information about who is sync, who is not. And from my discussions with parity folks, they do not seem that it is desirable, at least the way we described it. So for now, we will be doing this and we'll continue having discussions with them. If we can come up with something that will satisfy both sides, we'll be happy to contribute, of course, but otherwise we just need to get it fixed on our side. Okay, there are almost the time. Anything we need to discuss before we stop the recording?
Did you have any updates on your side, Lichen?
Oh, just the one issue that I found in the pre-stress test. That so, in short, I can't sync the pre-stress network due to the network, but we can do something to improve this situation. It's kind of that in the substrate default settings, they are kind of for the chains that don't expect too many huge blocks. Well, basically,
or slow network.
Yeah, or slow network. But in our case, for a storage chain, we do have a great chance that we'll have a kind of a huge blocks, which is close to the capacity of the block space, which is kind of a pain to sync without a decent networking, which is unfortunately you can't expect the people running from home to upgrade their network easily. So maybe we can do something to.
Yeah, we actually had this
that.
problem before, right? It's not a new problem, just resurfaced.
Yeah, this time we kind of located this problem more specifically. Last time it's shadowed in the another problem, which is the duplicated block request. When you requesting the blocks from other peers, we can send a flood of duplicated requests to that peer. That will make the another peer think that's a better peer and then disconnect. And in this case, this time we identify more specifically the timeouts cost for why I can't sync the network.
Yeah, they basically have a size limit and they have a time limit.
Yeah.
So we do fit the size limit, but on Lucheng's network, there is no one around China right now that you can use as a source for syncing. So it's very slow for him to actually get those blocks. And in some cases, he cannot get them in time. So the connection drops because there is no things happening. And then he reconnects and asks the same block again. So his reputation goes down. And he tries until he's blocked completely. And from that, unless both peers restart, because Substrate doesn't have any persistence, unless you restart both, you cannot connect anymore at all. So we either need to increase the time or decrease the size or get to chain better internet.
Well, that'll be a problem for a lot of people with stress test if we don't have a good balance of servers.
Yeah, exactly.
Bootstrap nodes. Yeah. So just so I understand, the problem is that the peer, Lucheng, your node is requesting the block from Nazar or the Bootstrap node, and that block is so big that the latency of sending
it downloads blocks in up to 64, in the batch, and there is a time limit for that batch to arrive. If it doesn't get through in time, then it just drops connection.
Actually, I'm not 100% if that is time limit for sending the whole response of 64 blocks, or it's just sending back 3 blocks. The target is just sending back the 3 blocks data, and that leads to the timeout.
It doesn't send blocks one by one. It takes 64 blocks, it encodes them together, and then sends as a one blob. Until you get the whole thing, you cannot actually decode it. So until you get the whole thing, nothing is happening from the networking point of view. It's timing out the response as a whole, and that causes connection to be dropped.
Actually, from the log, I observed that even I request for 64 blocks, you are only trying to sending back 3 blocks of data, which already like leading to the timeouts.
Right. That's in case those blocks are too big to fit in response. There are like two limits. One is the number, and the other one is the size.
Yeah, makes
There's
sense.
a cap on the data stream size, and where we
It's
exceed
like
that
10
at 3
megabytes
blocks.
or something. Yeah, so 3 blocks about 3 megabytes each is about as much as you can put into it.
Yeah, it
And you have 10
must
seconds
be
to
bigger
respond.
than must be bigger than like 10 megabytes. Maybe
So basically,
16.
unless you have 10 megabits sustained, you will not be able to download it.
Yeah.
Are any of these constants like timeout or the size of this data stream or the number of blocks, max number of blocks in a request, are any of these configurable?
They are constants,
they are
like literal constants in Substrate.
It's not configurable. It's not configurable right now, but I do like have a suggestion that if we really want to have a like kind of workaround for the short term, we can, like take those parameters like for our purpose, like and compile the node and the like the binaries for our.
Once we have a fork, we can customize more things, right?
Yeah. Be careful, slippery slope.
So there's no like a clean solution at this moment.
I mean, it does protect from some of the denial of service attacks when you're like sitting, like pulling data too slowly just to like exhaust all of the connections or something like that. So it does make sense. It's just like, I don't know. There's no perfect solution here. We basically need to like define what the minimum requirements of farmers is and configure protocol accordingly. And either make those parameters exposed or just customize them in the fork. Ideally, that would be just configurable on the config level.
Do we have an issue open for this right now?
There is in our repository and there is in Substrate as well.
What's the issue number? For our repository. I expect this is actually going to be a major problem for the pre-stress and the actual stress test. We probably need to prioritize resolving this, especially considering the number of
one on
Chinese.
The first page. I believe Substrate should be linked from here.
Okay.
Okay, that's one issue. There is a newer one. Lucian, can you post that one in this discussion as well, so we have reference to it?
You mean the issue in our repo?
Yeah, post a comment in our repo with link to that new issue in Substrate.
Yeah, sure.
Okay.
Let me find it. Oh, it's 391.
It's the one in our repo. Yeah. Okay. What are we thinking right now? Is the solution to this, Nazar, or at least the workaround?
I think a reasonable workaround is to either increase time or decrease the size. I think decreasing the size is better because you will have like more frequent progress, I guess. It will reduce efficiency a little bit, but at the same time, what can we do about it? Just probably customize it in our fork and ask priority folks if they want to see that as an option on networking. So like different chains can customize that to their liking. It's clearly like no size fits all kind of situation. It's very specific, and different networks have different assumptions about like validators or block producers or whatever they call them. So
why do you prefer changing size over increasing time, having that we know that Chinese network has obvious features?
I mean, It feels like there is always a preference to have incremental progress. So if you're like pulling a lot of data, you will basically wait 30 seconds before you start importing blocks. And if you have a shorter time and smaller size, then you will get the update more often. So instead of like having 6 lines in your like terminal output that say 0 blocks, 0 blocks, 0 blocks, and then like 20 blocks, you'll see like 2, 2, 2, 2, 2 all the time. So you like feel something is happening. Also, if something breaks in the middle, there is a higher chance that something is already downloaded and imported, rather than like all the data is dropped because like it's broken in the middle. So not going too small, but I think we can decrease it like 3 times probably in terms of size, and that should be much better. It will be like 3-4 megabits per second, or maybe like 3 megabits per second assumption for the farmer, which is reasonable, I think. And from there, we can see like if there are many complaints in the community still that they cannot sync, then we can discuss what to do about it next.
Would it be possible just to limit it to 1 block for now until we can confirm that that's working?
It's not about the number, it's about the size. If
Okay.
blocks are like 4 kilobytes, you can take 64 of them and they'll still be like really small. So it's not about the number, it's like total size.
Okay, but I mean, I guess could we just make it so that like whatever the max block size is for our blocks, that's the max limit. So like it can't be more than like 1 big block.
That will not work because, as Lucien said, in case where he times out, it's already 3 blocks. And the max in Substrate is 64. So however small we make it, it'll still likely exceed the size that is configured in terms of size. The problem is not the number, the problem is the size. So we need to decrease that size.
I guess I'm saying, can we fix the size so that it is no more than one of our biggest blocks? So like 3.755 megabytes, whatever that is. Can we just make the size that so that when we have like these giant blocks, we only get 1 block at a time?
Yeah, that's the plan.
Okay. So in the early, so just so everybody's aware right now, this wasn't obvious to me. I had to kind of figure this out last week. When you sync the network right now, you sync like the first like 2,000 blocks are like gigantic blocks, like 3 to 5 megabyte blocks, and then everything else after that is like small blocks. So you have this really slow sync, and you're like, "What's wrong with my network?" And then all of a sudden you get like rocket sync, and you're like, "What happened?" It's because you have these different blocks. So
because the first ones are seeded history, and then the new ones are produced are only headers for now because we don't have transactions.
That's right.
Okay.
Well, there's vote transactions technically. So there's still transactions, but they're pretty small. It's like 50 kilobytes or 40 kilobyte blocks, I think, with just the vote transactions. Okay. We're way over time, so we probably need to close out here. Anything else, guys? Looks like Nazar had to step away. Okay. All right, let's close out here. Thanks everybody for watching. We will see you again next week with more protocol updates.